Good evening, everyone. Thank you for joining us tonight. Welcome to the Evexia Webinar Series. Our topic for tonight is NAD optimization is the first and necessary step for health and age management. My name is Destiny Thompson. I'm the Client Success Specialist for Evexia Diagnostics and will be your host for this evening. Today, I have the distinct pleasure of being joined by our guest, Professor Xingjiang Shi, founder and CEO of Genfinity Precision Medicine, and he will be our presenter for this webinar. Dr. Shi received his PhD degree in France and was quickly promoted to endowed professor, chief of experimental pathology, and director of diabetes research at the University of Florida. He was then recruited as an eminent scholar and the founding director of the Center for Biotechnology and Genomic Medicine at MCG. He has authored over 400 papers with an H-index of 74 and over 17,000 citations. He has also secured over $100 million in research grants and has been invited to speak globally. He was also named one of Georgia's top 20 medical researchers. He served in multiple and national, international scientific leadership projects. Dr. Shi is a serial entrepreneur, and his latest announcement aims to provide an end-to-end solution for healthy longevity via biomarker testing and personalized interventions. Joining Dr. Shi tonight will be Dr. Wayne Sedano, our Director of Clinical Support and Education at Evexia Diagnostics. Additionally, Dr. Sedano is the Director of Integrative Medicine Education for the College of Integrative Medicine and lectures and teaches internationally. Before we begin, we have just a bit of housekeeping, and we do encourage participation. So if you have a question, you may submit your question in the questions field in the right-hand area of the webinar interface. We will answer the submitted questions towards the end of the presentation. If your questions are not answered this evening, you will receive an answer by email within 1 to 2 business days. And without further delay, I will now turn the webinar over to Dr. Shi.
Good evening, everyone. It's my distinct pleasure to have the opportunity to talk to you tonight. Although my research career has touched upon many different disciplines, tonight I'm going to focus on one very important molecule. It's called NAD, or nicotinamide adenine dinucleotide. NAD is probably the most important molecule in life. All right, so here is the structure of the NAD molecule. This molecule is basically a dinucleotide. On the right side is the dinucleotide, is the nucleotide adenosine. And on the right side, you have nicotinamide-based nucleotide. NAD is a coenzyme that's really essential for life, and it's found in every cell of all living things. It catalyzes the reaction for more than 500 different enzymes, including the very important groups of enzymes known as the sirtuins, the PARPs, and CD38. The most important function of NAD is known to facilitate the hydrogen transfer through its 2 different forms, known as NAD+ and NADH. And the molecule is involved in the production of cellular energy in the form of ATP. It's required for glycolysis, the Krebs cycle, and oxidative phosphorylation. So why is NAD so important for not only aging, but for biological functions in general? We know that NAD is involved in many different cellular processes, including DNA damage repair, oxidative stress, inflammation. It also regulates circadian rhythm and intracellular calcium release. More importantly, NAD regulates the function of many proteins that are involved in cellular senescence, nutrient sensing, and it supports immune health, among many other functions that I'm now going to go through one by one. All these cellular processes are known to play very important roles in the healthy aging process. So what are the benefits of optimum NAD levels? There are many, and we are not going to have enough time to talk about every single one tonight. But among the most important ones, I already mentioned a little bit. So the most important function is if you optimize the NAD level, you can increase energy production. So many of the people who may feel tired or lack of energy are likely to be due to suboptimal or deficient levels of NAD molecules. NAD is also involved in regulating sleep, and better NAD levels can result in better sleep. And because its involvement in energy production is very important for optimum performance, obviously. NAD is also a very potent anti-inflammatory compound. So it can reduce inflammation, it can promote immune health, and it can also reduce insulin resistance. And it may provide better mental clarity, and it can also improve many other organ functions, including liver function and kidney function. The actual benefit from NAD optimization may vary from person to person and may depend on the cause or causes of the health conditions of concern. So what are the signs of low NAD level? And this may vary from person to person as well. Most people in their 40s and 50s may be suboptimal or even deficient in the NAD levels, but they may or may not feel it. But the common signs of low NAD levels may include chronic fatigue or lack of energy. It may include subpar performance or lack of mental clarity or sleeping issues, but poor health in general can be a sign of insufficient NAD level. Diseases either that occurred in the past or is still going on in someone may also be an indication of suboptimal levels of NAD. So there are many different appearance, physically or mentally, for the lower levels of NAD. How do we know that NAD is not optimal in a patient or just in anyone in general? The testing is really the only option to find out whether someone has optimal level of NAD. And so NAD testing is very important, but NAD testing is very difficult, and primarily because the NAD molecule is not very stable. If you don't treat the sample properly, and the NAD molecule can be degraded in a matter of hours, and that really makes testing of NAD extremely difficult, and many researchers and companies have attempted to develop methodologies to measure the NAD levels, and it can be done in research laboratories, and but there has been no NAD test for patients or for consumers until a couple of years ago. That's when Infinity Precision Medicine, a startup company that I started a few years ago, developed the first and still the only NAD test available on the market. So if you look at the localization of the NAD molecule, you can find the molecule inside of the cells or outside of the cells. The vast majority of the NAD molecule is actually localized inside the cells. So NAD inside of the cells is known as intracellular NAD, and NAD outside of the cells is known as extracellular NAD. And you can find the NAD molecule in the plasma, and you can also find them in other bodily fluids, such as the saliva. We call the NAD molecule in the plasma circulating NAD because blood circulates all over the body. And this is just a part of the extracellular NAD space. Now, I'm going to focus on intracellular NAD tonight, but extracellular NAD also plays an extremely important role in many different cellular processes. And the most known functions of NAD is attributed to intracellular NAD. With the Infinity intracellular NAD assay, you can measure the NAD levels in different cell types, in different tissues, and any tissue that you can get by a biopsy or surgical sample can be used for the test. But for patient care and or for consumer testing, obviously the most convenient sample type is the blood. Blood cells, both red blood cells and white blood cells, actually contain NAD molecules. The intracellular NAD assay from Infinity is a dried blood spot based assay. You can do a finger prick to make blood spots on a filter paper that's commonly used for newborn screening. You can also take a drop of blood from a vacuum cleaner and apply the blood onto a filter paper, and you let it dry for 2 to 3 hours. And then we have developed a special buffer that we call NAD stabilizing buffer, or simply NAD fixing buffer. And this buffer contains reagents that can stabilize NAD and dramatically slow down the degradation of the molecule. That's how we are able to measure the molecule even after days and weeks from the sampling. So the stabilization of the NAD molecules allow us to test samples from remote locations. We actually are doing the test for consumers and patients from over 50 different countries now. And we only started offering the test about a year ago. So it's becoming a very important tool for optimizing NAD and also for patient care. And I'll talk a little more about how you might be able to use the NAD test and the NAD supplements to improve patient care outcomes in your practice. The Infinity NAD assay is actually very reproducible. And this is a chart that shows the data from duplicate testing for a large number of samples. So each sample was tested twice, and the values from one test is plotted on the y-axis, and the second test is plotted on the x-axis. If the test is perfect, all the dots, which represent a sample, would be lined up on the diagonal. So, of course, no test is perfect. And the way that you can measure the performance of a test can be multiple ways. For one measurement, you would calculate the coefficient of variation, or CV. And the average CV for the NAD test is 3.1%. What it means is, on average, the result from two tests on the same sample has a 3.1% difference. So that's a very good performance. The second measurement is R-square value, and R is basically a correlation index. The perfect test would have an R-square of 1, but anything above 0.95 would be exceptionally well good test. And the intracellular NAD test, it has an R-square value of 0.98. The bottom line is we have a very robust, very reproducible, and a high throughput test for NAD. Now, once we have the reliable test, the first question we tried to answer is what levels are optimum? What NAD levels you want to achieve to have health benefit. And this is a very difficult question to answer for any test. And here, the way that we define the lower end of the optimum NAD level is based on the values we observed in very young people, in teenagers. We look at the distribution of NAD levels in a large number of teenagers, and the data indicate that over 75% of teenagers have NAD levels greater than 40 micromole, and 25% of the teenagers have levels below 40 micromole. We took the 25th percentile, which is 40 micromole, as the lower end of the optimum range for NAD. We think this is a reasonable level. Of course, this is debatable. The second way that we tried to define the optimal range is based on how people how they can at what level the patient would see improvement in physiology or in physical activities or in mental activities and so on. So what we normally see is that once we get the NAD level greater than 40 micromole, the vast majority of the people start seeing obvious improvement in their function. So that's the two ways that we help us to define the lower end of NAD levels. And this is probably a moving target, as we have more data, and this might change in the future. But I think by and large, the 40 micromole is a very good starting point, and it can be used to guide us on NAD optimization. Now, the optimum range also have a higher end. The higher end of the optimum range for NAD is currently not very well defined. And this is an even more difficult question to answer. In our observations, most people don't have levels above 100 micromole. And even with supplementation, very few people have NAD levels that are near or higher than 100 micromole. And we do have a number of individuals who have NAD levels that are more than 100 micromole, even 150, and they usually don't see toxicities or anything really bad. But to be cautious, I counsel consumers and patients that we may want to stay within the 100 micromole level. So the optimum range for now is between 40 micromole and 100 micromole, based on the data we have so far. So the second question we tried to address is whether and how NAD levels decline with age. And based on previous studies in animals, it's pretty well established that NAD levels do decline with age, but how fast and when the levels decline in human subjects was not addressed at all. So on this slide, you see the distribution of NAD levels in different age groups. The first one is the teenagers that I talked about, and that's the data we use to define the optimum range. One surprise was that a significant proportion of young people in their late 20s and early 30s already have reduced NAD levels, and some of them even have very deficient levels of NAD. And by the 40s and the 50s, and the levels already reached close to the bottom, and they are not so different from what we observed in individuals who between 55 and even 90, 95 years of age. So there's a very rapid and sharp decline starting in the later 20s, and it continues to decline, but then it kind of stabilize after the 5th and 6th decade. The next question we want to answer was, can we really optimize intracellular NAD level? And the answer is absolutely yes. And there are potentially many ways to do it. And I'm not going into the details on this slide. I'll come back to this. It's shown on this chart before NAD supplementation, and the levels are quite low. And even after 2 weeks of supplementation, you can get the levels up significantly higher and into the optimum range for almost everyone in this particular study. And this is just a comparison between people who did not receive supplementation on the left and people who received supplementation on the right. So you can see the contrast. And so what it means is, there are really ways to get the NAD level higher. It's doable. So what are the possible ways to elevate NAD levels? Well, actually, there are many different ways. If you look at the NAD, the structure of the NAD molecules, you can figure out a number of ways that one can consider to elevate the NAD levels. The first one that was tried was pretty apparent is, well, why don't we use the NAD molecule? And the NAD molecule can be produced using chemical synthesis methodology, and it can be done. And actually, it was given to many patients through various routes, including intravenous infusion. Now, then if you look at the structure of the molecule, as I said, you have two components. On the right side, you have the adenine nucleotide, and on the right side, and this is called nicotinamide mononucleotide, or NMN. So you can use the NMN potentially as a precursor for the body to make their NAD molecule, and that's a possibility. And then if you look further, if you chop the phosphate group from NMN, you have the nicotinamide riboside molecule, or NR. And NR has been used to elevate NAD level as well. If you go down further, you will have the nicotinamide base. And nicotinamide is a form of vitamin B3. And it has been suggested that nicotinamide can be used to make an NAD molecule. And we have seen some outcome with nicotinamide. And I'll give you a little more detail on the observations we had. So let's dive a little more into the details on how we can increase NAD level. So NAD molecule, the intact molecule, was the first one that has been used in clinics, and through both IV infusion and now through intramuscular injection, and there are patches and there are creams, and people have tried many different ways to deliver the NAD molecule directly to human subject or patients. Now, NAD IV infusion has been successfully used to treat some indications, mostly neurological conditions, Alzheimer's and Parkinson's, and with pretty good outcome, at least in some patients. It has been used successfully to treat addiction, and it also works quite well, at least in some patients. However, our extensive studies have shown now that NAD IV infusion really cannot increase NAD levels inside of the cells. And the data are black and white. There's no gray zone. And we know now that NAD IV is useful, but you have to be careful in selecting the indication for treatment. And for longevity or for performance purposes, you probably want to increase the intracellular NAD level, and the IV is not going to do the work. We have very limited data on intramuscular injection, and the limited data we have indicates that this delivery route may not be very efficient for many people, but we still need to get more data for to see how much and in how many people this route of delivery can increase intracellular NAD. And more data will come out in the near future. So why the NAD molecule delivery cannot increase intracellular NAD? And there are probably a number of different reasons. And the two most obvious reasons include, number one, the NAD molecule is too big to get inside of the cells because there's no transporter that has been found so far. And the second possibility is that NAD IV is only given occasionally, and you are only given a few hundred milligrams of NAD 1 to 5 times, and you are really not delivering enough NAD molecules into the body. And the theory is that even though NAD cannot get inside of the cells, but it can get broken down into NMN, NR, or nicotinamide, and those pieces can get inside of the cells and used to remake NAD. But data indicating that this process is not very efficient, at least. So to increase intracellular NAD levels and delivering the NAD molecule may not be the best way. Now, so NAD is too big. Now you may say, okay, why don't we use nicotinamide? That's the smallest component of the NAD molecule. Well, and that solves multiple problems. Number one, can be absorbed easily. You can get inside of the cells easily. But the efficacy of elevating NAD by using nicotinamide is not very good because multiple enzymes, multiple steps are required to make an NAD molecule from nicotinamide. And we have seen very high levels of NAD in a few individuals that only use nicotinamide as a supplement. But the number of individuals that can get their NAD higher by using nicotinamide is really low. So it may work very well for some people or a small number of people, but it's not a common approach that would work for the vast majority of individuals. Then you have the intermediate precursors. You have the NMN, you have the NR, and many people believe that NMN and NR could be the best ways to elevating NAD levels. And there was a tremendous debate in the last decade or so as to whether NMN is better than NR or NR is better than NMN. And we have very extensive data on using NMN, and we also have a lot of data on NR, but much more limited than NMN. And because NMN is a one-step precursor, you only need one enzyme to make NAD from NMN, but you need two different enzymes to make NAD from NR. First from NR to NMN, and then from NMN to NAD. So if someone is deficient in the enzyme that makes NR to NMN, and giving people NR is not going to elevate the NAD level, and so that's probably the only difference between NMN and the NR. And our data indicates that both NR and NMN work quite well. Now, if you just look at the either NMN or NR, there are many different ways that you can deliver the precursor to the body, and you can use and NMN, both NMN and NR are very water soluble, so absorption is usually pretty good. But you may have a degradation of these molecules into a nicotinamide, and so some liposomal or sublingual form of NMN or NR may work better than just a oral form of the NMN. And however, the products, either the liposomal or sublingual NMN products on the market, really don't make much a difference from just the regular NMN powder. And the reasons are unknown, but I suspect that most of the sublingual or the liposomal form of products have a much lower dose, and even if the absorption is improved by you are given lower dose, so the final outcome at NAD levels is not improved. And so, and the second point that could be very important is either NMN or NR are not sufficient, and they are potentially other ingredients that can improve the efficacy of raising NAD level, but also you may have to improve the cellular function in order for the NAD molecule to provide the best benefit to the person. So you really have to use the testing to find out what product is working for the particular patient, and without the testing, it's very hard to guess. And guessing is not going to solve the problem, but the testing can help you to figure out what's working, what's not working. So testing is really the key. In addition to the precursors, there are at least a couple of other ways that can be used to increase the NAD level. I'm one step ahead of myself. And here on this slide, what I want to show you is the special formulation that we have came up with, and this is an NMN-based formulation with 4 ingredients, and NMN and 3 other ingredients that I cannot quite disclose at this moment, but I'll be able to disclose the ingredients in about 2 weeks. And thus we submitted the patent application. And this product works extremely well, and the clinical trial that we have done is shown on the right. You can see after 2 weeks, the NAD level on average is increased by over 100%. And after 4 weeks, it continued to increase a little bit. But 2 weeks is really what you need to get someone's NAD levels to the optimum range. So you don't need to wait for a long time to retest to figure out whether the product is working or it's not working, or you have to adjust the dose. So, all right, now I want to talk about very briefly enhancers of the enzymes that are involved in making the NAD molecule, because these enhancers can be another approach to elevate NAD levels. And there are also enzymes that can degrade the NAD molecule. And actually, a number of enzymes use NAD as a substrate for their enzymatic function. And during the reaction, the NAD molecule is degraded into nicotinamide. And if you can find inhibitors for these enzymes, you can potentially slow down the degradation of NAD and then maintain the NAD level. And there are a number of NAD degrading a number of inhibitors that have been found that can inhibit the NAD degrading enzymes. The most common ones are quercetin or epigenetic, and these are supplements that can be found on the market now. How well they work in the body is not clear. In vitro studies, they actually work quite well. And we are now doing studies to demonstrate, whether these supplements actually work or don't work in the human body. Or more importantly, what's the dosage required to provide a functional benefit. So, like any other treatment, proper dosing is really important. And unfortunately, the dosage required to optimize NAD level can be very variable, and it can be different from one person to another. And unfortunately, this can be only determined experimentally, and so you have to use the testing to find out. And the second point I want to make here is, with most supplements on the market, and the efficacy in elevating NAD is not very good for the vast majority of the patients. And the major reason is the dosing is not sufficient to get the NAD level high enough. And in many cases, the recommended dosage doesn't elevate NAD level at all. And the third point I want to make here is, there are a small number of individuals who take NAD supplements can have too high levels of NAD. And what I mean by that is, it goes to over 100 micromole. And I have one person who got his NAD level to over 300 micromole. That's definitely the level that I wouldn't want to see. So, how do you figure out the right dosage? Well, the only way is you test after the treatment, and you use the testing results to adjust the dosage. You can adjust the types of supplements or different treatment approaches. So testing is really the starting point to get someone's NAD level optimized. So now I want to give you some examples very quickly. So this is the history of NAD optimization for my babysitter, actually. And she's a 68-year-old lovely lady. As you can see, her NAD levels were very low at the baseline, the first time point. And then she tried different supplements on the market, and it really did not move the needle very high at all. And then she started using our special NMN formulation, and her at 1,000 milligrams per day, and her level shoot in to about 150 micromole, and that was kind of too high. And we told her to reduce the dosage to 500 milligrams, and she got it down to 50 to 75 micromole, and that's the perfect range based on our current knowledge. And she felt improved energy, and she actually had more hair growth and was worked very successfully for her. The second example is myself, and I tested myself very frequently. From the very beginning, my level was also very low. I'm 60 years old now, and I was 58. And as you can see, I used different levels of supplements and got it very high. I stopped the supplementation to see whether it will come down. Surely it did. After about 4 weeks, my level was approaching baseline, and then I increased my dosage a little higher. It went up a little higher. I stopped it again. It never came down, and then I increased the dosage to 1,000 milligrams, and I got into the green zone. And you see, I need about 1,000 milligrams of NMN to get my levels to 50 to 70 micromole, but my babysitter only needed 500 milligrams of NMN. So everyone is different. And this is a customer who tried to test the levels of NMN required to optimize his NAD level. This is not based on my advice. He just wanted to try it. That's his baseline. He started with 100 milligrams of NMN and then gradually increased to, I believe this is 250, 500, and so on. And he really needs, 2,000 milligrams of NMN to get his level to about 100 micromole. And he settled down at about 1,500 milligrams of NMN per day to get it to the 70, 80 micromole range. So as you can see, everyone requires a slightly different dosage to maintain the desirable NAD level. And what depends on what level you want, and you can use the testing to get your level to what you think is the best range. And obviously, I recommend, if possible, 50 to about 80 micromole. And if you widen the window, it's 40 to 100 micromole. All right, this is my last data point, and I think this is a very important one, and especially for providers like yourself. And that is NAD levels really have a major impact on how patients respond to other treatments. And I have 2 examples here. One is anti-inflammatory treatment on the left, and second one is anti-oxidative stress treatment on the right. So we divided the patients into 2 groups based on their NAD level, NAD high and NAD low. And for the anti-inflammatory treatment, you can see about 80% of the patients have lower than their inflammation if they have a higher NAD level. Only about 20% of patients did not respond. When the NAD level is low, not optimized, only about 30% of patients responded, and 70% of patients did not. If you look at the oxidative stress, and the percentages are different, but the trend is almost the same. And we also have other evidence suggesting that NAD levels may have a major impact on how patients respond to other treatments. This is just the beginning. I think getting the NAD optimized is really the first and necessary step towards better patient care, and for many different purposes, not just longevity and performance, but in treating potentially many other conditions or diseases. So the final point I want to make is testing is the key. You really want to test to start, and based on testing results, you can do personalized and precision intervention. After the treatment, you want to retest again, and this is going to be a loop. It's testing, personalized intervention, retesting until you achieve the best outcome for your patient. Unfortunately, there's not going to be one size fits all solution, and we have to test and we have to adjust the treatment protocols accordingly. And I want to thank you, and I wish you all the best in your practice and in your own journey of health and wellness.
Thank you, Dr. Shi. That was wonderful. I mean, we actually do have questions. The first one I'll ask if there will be. Absolutely will be. Questions that don't get live as well. Those in a business. So our first question, what are the mechanisms behind the clinical benefits? Examples, reducing insulin resistance.
Yeah, yes.
The first question is, what are the mechanisms behind the clinical benefit? Examples, reducing insulin and other metrics.
All right, so the underlying mechanism of NAD is through the regulation of expression of genes. For example, NAD is required for the function of sirtuins, and sirtuins are involved in acetylation, so it changes the structure of the chromosomes and thus regulates the expression of genes. And many of the longevity genes are regulated by sirtuins, and the sleeping genes are also under the control of NAD dependent genes. And everything can be traced to the structure of the chromosomes and the expression of the genes. Obviously, you can, depending on the functions you are talking about, you can have slightly different mechanisms. And for example, they are receptors on neuronal cells and the immune cells for the NAD molecule. So you can change the signal transduction of the cells through the NAD molecule. So, as I indicated, NAD is involved in the function of over 500 different enzymes. You can imagine that almost no cellular functions are not tied to the NAD molecule.
Okay. Question number 2 is, how is NAD testing clinically relevant and sustainable as an isolated marker?
Well, so I think we are only at the beginning of how NAD testing and really NAD optimization, not just testing. Testing is only one part of the equation. You really want to test, and the testing will guide the optimization of NAD. So I would rather prefer to really focus on how we get NAD optimized. So why NAD optimization is important clinically? First of all, many patients can directly benefit from the NAD optimization protocol, especially for patients who have chronic fatigue and because NAD is required for energy production, and most patients who feel tired and will have improved energy. And that's just one example. And some patients may have, let's say, arthritis patients, and you have a lot of joint inflammation. And NAD is actually a very potent anti-inflammatory compound. And we do have a number of patients that have improved symptoms for arthritis, joint pain, and muscle pain, including myself. And my physical activity have dramatically improved. And we don't have time. I can tell you my own story. My tennis game became 20 years younger, and it's really unbelievable. And I think NAD is potentially used for a number of other indications, and especially for diabetes patients and diabetic complications, because NAD has been shown in our studies and in other studies as well that NAD can really improve insulin sensitivity. So, there are a number of indications that can benefit from it, and what we may want to do is we'll ask a provider and who is now testing every single patient in his clinic, and he's using the NAD supplement to treat the majority of the patient, and he's getting unbelievable clinical benefit. And we have talked to him, and he's very happy to come here and share his personal experience with within his clinic, and how he's using to deliver patient benefits. It's it's an area that's going to expand very quickly, because the benefit is very obvious in many different situations.
Wonderful. Thank you, Dr. Shi. We do have a lot of questions coming in, so we will respond to those in 1 to 2 business days via email. We'll also be sharing our contact information at the end of this PowerPoint. Dr. Shi, we do ask that you go to the next slide. We have just a few more things we'd like to share. As we have Dr. Wayne Sedano on our team, we have Ask the Doctor. This is a free service available to all of our Evexia clients. This can be accessed via your Evexia clinician portal. And Dr. Wayne Sedano is our Director of Clinical Support and Education, and he will help you review test results, clinical conditions, further test recommendations, or answer any other questions you may have via email. In addition, your clients also have the option of scheduling either a telephone or video conference for a fee. We'll go ahead and move to the next slide as well. We want to show you how to actually order the test. So the steps are simple. You'll want to start by logging into your Evexia Diagnostics account. And pictured to the right, you'll see the menu options. You'll go ahead and click Evexia link, lab orders. And after that, you will want to select the patient or create a new patient that you'll be ordering the test for, and click Add New Lab Order. Once you do that, you'll select specialty testing, which is pictured to the right, and click on the Add Infinity test to order. In step 4, you'll use the search box to locate your desired test and add it to the cart by clicking the blue plus symbol next to the test name. In step 5, you'll want to preview the order. There's a green button that pops up once it's added to your cart to review all the patient details and make sure if any edits are needed, agree to your terms, and click Place Order. That is all that we have for you guys tonight. We thank you for joining us. Again, if there are any questions, our contact information is here on the screen. You can contact us via email at info@evexiadiagnostics.com or by phone 5 days a week at extended hours 8 a.m. to 8 p.m. Eastern Time at 888-852-2723. And again, we will have a recording of this webinar available in the next few business days. We thank you, Dr. Shi and Dr. Sedano, for this informative presentation. And we thank all of you again for joining and participating. We had lots of great questions. So until next time, from everyone at Evexia Diagnostics and Infinity, stay healthy, stay safe, and we wish you all the best on your pathway to wellness.